All right, so I've given you your sheet for section 2.3. So like we did last time, what I asked you to please do is I'm going to give you 3 or 4 or 5 minutes. I want you to do the first 6 problems. I would like you to do your basic graphs. And then I'm going to give you 2 things to do in addition to the basic graphs, just to practice what we did last time. I would like you to, oh, sorry, it's this one right here, right there. Sorry about that. What I would like you to do for the x squared graph is after you've done the basic graph, please also graph x squared minus 3. And then on the square root graph, I'm just picking these ones for no real reason. I'd like you to graph the square root of x plus 4. Just to review what we did last time. Yes? You need 2.1? You need 2.2? You have 2.2.
Oh.
I gave out 2.3 today.
Oh.
You sure can. They're still free. You ask next time. Costs $5.
So you just walked in, we're working on the 6 basic graphs right now, the first 6 grids. Just another minute or two more to make as much progress on the 6 basic graphs and then the 2 translations that I've put on the board just to refresh our memory. Going to start with the x squared graph. So I'm just going through the basic points. If you are still at the place where you need to write out your table of values, great. Do whatever you need to do to be successful. Okay, that's all I'm doing is going through the table of values we made the first day when we first introduced these graphs. So I'm just going to go along the x-axis, and remember, whatever x value I put in, I'm squaring it. So I'm going to start over here on the left. I'm going to start with -3 because when I square -4, it becomes 16, and that's not on my grid anymore. So -3 squared becomes 9, so I'm going to put a dot there at 9. -2 squared becomes 4, so I'll put a dot there. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And finally, 3 squared is 9. And I'm just reminding you, I'm sure you know this, my only limitation is the grid that I've given you, which is 10 by 10. If we had a bigger grid, we could do more points, okay? But this gives us the essence of the graph and what it looks like, which is all we're going for. I'm going to put arrows on both ends to remind everybody that this keeps going. Okay, that's your first basic graph. I'm just going to plow through these. If anyone has any questions about the basic graphs, if something's just not clicking for you, please don't hesitate to let me know, because I hope you saw this on the first test. The way the second test is going to work is I'm just going to take stuff we've done in class. I'm going to change the numbers. I'm going to throw it on a test. Okay, so if you understand it here, hopefully you've validated that by doing your homework, and then you're going to do great on the test. I also asked you as a second question is to then graph x squared minus 3. Just to make me happy, because I know that's what you really want to do. What does this minus 3 do to the graph? It's not going to move it to the right because it's outside of the squared. That's a good thought, though. It's down, yes. So the x squared, I'm just going to put some parentheses around it. The x squared is the function. And that minus 3 is outside of the x squared. So that means I'm taking all those x squared values, all those y values, and I'm subtracting 3 from them. That's why it's not right. Well, if I had asked you to do this, I'm not going to graph it. But if I had wanted it to move right 3, I would have done, x minus 3 squared. The minus 3 would be inside the parentheses. So that would be right 3. Okay, so that was not what I asked. So note the difference between that. Okay, it's not, we're still learning, so it's not a problem to make that mistake and to learn from it. So now what I'm gonna do for my green graph, the x squared minus 3, is I'm just gonna drop all these points down 3. This is just a nice straight translation down. And then I'm going to connect the dots again, and there's my graph. So far, so good. The next one I asked you to do, and they're in no particular order. I think I just copied and pasted from the last sheet. This is the absolute value. The absolute value just takes every input and makes it positive. So again, starting on the left, I'm just going to pick some x values, and I'm gonna make them positive. So when I pick -6, the y value is going to be 6. -3 is going to be 3. 0 is 0. 1 is going to give me 1. 3 again is going to give me 3, and then 5 gives me 5. Okay, whatever X values you pick, your Y values are just positive. It's the absolute value. It should always look like a V. I'm going to move on unless somebody has a question, comment, or concern. The next one is the X cubed graph. So just similar to the other ones, I'm going to pick some X values. My only constraint is what's going to fit on the grid that I've given you. So when I cube -2 times -2 times -2 becomes -8. So I'll make a dot down there. -1 times -1 times -1 is -1. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. And finally, 2 times 2 times 2 is 8. And so this, again, I'm just doing enough X values to get the general shape, and I just missed one. Just terrible. I can't talk and write at the same time. Okay, but you got that little bendy part in the middle. The next one is the square root, and hopefully you've done this a few times and you remember the square root is the only one of our basic graphs that has a limited domain. My domain for the square root starts at 0 because this is a Cartesian coordinate system. It's not a complex coordinate system, which, by the way, if you want to have some fun in life, take complex algebra when you get to university. You do algebra on the complex number system, you never have so much fun in your life. It's great. Anyway, so this is not complex algebra, so we are just dealing with real numbers. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And my choice of X values was intentional because I want to do this sketch nice and quick. I don't want to have to think about it anymore. So I just picked things that have a quick and easy square root. No decimals to worry about. And there it is. So here is my square root graph. I then asked you on the board to do the square root of X plus 4. So noticing that the plus 4 is inside the function with the X, what is this going to do to my graph? I'm sorry? Yes, to the left, 4 units. Yes, so I'm just going to take my basic points, 1, 2, 3, 4, and I'm going to move them all left 4 units. And it looks like the same graph that's just been translated because we're doing translations. 2 more. The cube root graph. I'm going to pick numbers that have a nice, quick, and clean cube root. So the cube root of -8 is -2. The cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. And the cube root of 8 is 2. So this is my graph. Looks very similar to the X cubed graph. And last but not least, the identity function. Every Y value is just the X value. It's the same thing. So -5, -5, -1, -1, 0, 0, 2, 2, 4, 4. And we're just going to get this lovely line there. There's your 6 basic graphs. I'll mention this one more time as you're still getting used to this. Okay, so you're not gonna see me again for a little while after we leave class today. I've printed out some blank graph paper. Grab 5 or 6 sheets. I can print more if there's none left. If you can't print any at home, and practice. Okay, that's the way to indel these into your brain, is to practice, practice, practice. So that way, when I put one on the test, you're not going to freak out about it. Okay. All right. Before I move on, we're going to go to section 2.3 today now. We haven't done anything new yet. Questions, comments, concerns? All right, well, as I promised last time, we've talked about translations. Now we're going to talk about the things we do to the graphs to kind of change their shape a little bit. So we're going to talk about stretching and shrinking. So the first type of stretching and shrinking is going to be our vertical stretching and shrinking. I do have a little typo on this sheet that I'm going to address right now. In this first one, it should say if C is greater than 1. So I apologize for that. I'm not a great typist, and you are bearing the consequences. My first question here is the same first question I asked last time. I also asked this before I turned on the camera. When we see this notation, f of x, that is referring to what value? The Y values, yes, thank you for being awake. I appreciate that. This is representing the Y value. Again, the same pattern as last time because math is just all about patterns. So what do you think is going to happen then if I have this kind of notation? If I take a constant times my f of x or a constant times my y value, what do you think is going to happen to the graph? Or maybe that's a bad question because it probably depends on what the y values are. But I'm going to multiply. Let me just ask this question another way. Here's a better question. I'm going to take a number. This notation means I'm going to take a number c, whatever it is, and I'm going to multiply it by what? The y's. Okay, so that's what this notation is telling me is I'm going to take a number c and I'm going to multiply it by my y values. So then there's two situations that can happen, but all you're going to be doing is multiplying by the y values. That's how this is going to work. So if c is greater than 1, so if it's 1.5 or 2 or 5 or 6, if I multiply 5 times all my y values, what do you guess is going to happen to the graph? Are the y values going to be bigger than they were or smaller than they were? They're going to be bigger. So if all my y values are going to be bigger than they were, I'm going to stretch the graph. Okay, so if c is greater than 1, then the graph c times f of x is stretched vertically by a factor of c. I'm just writing kind of mathematically what you summarized for me or what we tried to think through. And we're going to do some problems and we'll see how this goes. Well, then the other thing that can happen if c is a number between 0 and 1, so it's fractional, it's like a half or a third or 2/5. Okay, if I multiply all the y values by a half, let's say, are those y values going to get bigger or are they going to get smaller? They're going to get, you take half of everything it's getting. If I take half your paycheck, are you getting paid more or are you getting paid less? You're getting less. So the graph now is not going to stretch, it's going to shrink, it's going to compress. Okay, so I'm going to write the same thing here. If my value of c is between 0 and 1, then the graph of c times f of x is shrunk by a factor of c. Now, all that is a lot of words for something that I'm expecting. If you feel fairly comfortable with the translations, I'm hoping you feel fairly comfortable with this. It's a very similar process. So I'm going to give you another moment if you're still writing, but we're going to move down to example 1. I'm going to work through example 1 with you, and then I've got an example for you to work as well. But I've given a graph right there, just a pretty standard graph with a starting and a stopping point. And what we're going to do is, given that this graph right here represents f of x, we are going to graph what 2 times f of x looks like. So just what you told me, all this means is I'm going to go through each point, I'm going to look at the y value, and I'm going to multiply the y value by 2. Yes, thank you. Participation's awesome. So let's go through each point, the y value. We're going to multiply the y value by 2, and then we'll plot the point. So this first point over at the left, what's the y value of this first point on the left? It's 0. So 2 times 0 is 0. So I'm just going to make a red dot a little bigger so that it stands out right on top of the black dot. The next point, what's the y value of this next point? 3. So when I multiply that by 2, it becomes what? 6. So the new point is at 6. Now I'm not moving it, I'm not counting up 6 more units. The new y value is 6. We're not translating, okay, we're stretching. Okay, so the new y value is at the y value 6. Does that make sense? Sometimes students want to slide it up 6 additional and go up to 9. That's not what we're doing. We're not translating here. The middle point, again, has a y value 0. What's the y value of this point in quadrant 4 down here? -3. So what do I get when I multiply that by 2? -6. So I'll make a dot here at -6. And then the final one is at 0. So notice, this has not been translated. My graph is in the same position. Okay, but what has happened is the shape is going to change. Now what happens is like a wee way up and then wee way down, and there we go. And there's my new graph that's been stretched by a factor of 2. Question for me? So your problem is super similar, okay? The one right next door, so you'll be able to see both. Now, instead of multiplying by 2, in the next example, you're multiplying by 3. So see how the graph looks when you multiply all the y values by 3. I'm going to get started. If you get something different than I get, that is a great opportunity to ask a question. I'm going to go through. I'm going to multiply all of my y values. F of x stands for my y values. I'm going to multiply all my y values by 3. And the nice thing is 3 of the points on this graph, the y value is 0. So over here on the left, this y value is 0. So 3 times 0 is 0. You told me a moment ago that the y value of the second point was 3. So 3 times 3 is 9. The next value is 0, so 3 times 0 is 0. This is -3, so 3 times -3 is -9. And then finally, this one's 0, 3 times 0 is 0. And here is my new graph. It's stretched way out. And there it is. Anything we need to talk about more before I give you another problem to do? All right, well, flip the page. Example 3, it's the same thing, except I've just changed the value of c. So give it your best shot. See how you do. So I'm going to multiply each of the y values here by a half or 0.5 if you prefer decimals and if you're using your calculator. So each of these y values is a half. Again, the end points and the middle, the y value is 0, so it's not a big deal. But the two interior points. So you told me earlier the y value here is 3. What's 3 times a half, or what's 3 times 0.5? 1.5 or 1.5 or 3 halves, whatever floats your boat. Okay, so 1.5. Now you might be saying, Perkster, how do I graph decimals? You're crazy. All you got to do is 1.5 means go up 1 and then half. So I'm just going to go in between 1 and 2 there. I'm approximating. Okay, 1.5. 0 times a half is 0. This is -3 is the y value. So -3 times a half, or -3 times 0.5 gives me what? Yeah, beautiful, -1.5. So I go down 1 and then another half right there. And then last 0 times a half is 0. And so I got this little compressed graph, whee, like that, little baby graph. Well, maybe the fraction fouled you up a little bit, so I'm just going to slide over. I'd like you to do this next one. I've changed the shape of the graph slightly, and this time you're taking 1/3 of the function. So I'm going to multiply the y values here by 1/3. So on the left, that y value is 0, so it's going to stay 0. In the middle, the y value is 3. So what is 1/3 times 3? 1, yes. So 1/3 times 3, if I have to do this, 3 times 1/3 equals, well, I can write this 3 as 3/1, and then, oh, canceling, yay, and I end up with just 1. Okay, so if you wanted to do the multiplication, or you can go into your calculator and put in 1 divided by 3 times 3, and you'll see what you get. So it's going to be 1. And then over here on the other side, 0 times 1/3 is 0. So we get this little flat curve right there. I'm just moving along. I'm not seeing questions, but if you got one, raise your hand. Let's talk about it. Love to clear up any issues. 2 more examples like this. So example 5, that same half circle that we just dealt with, go ahead and multiply that one by 1.5. when I multiply my y values here by 1.5, so on the left, this y value is 0, so times 1.5 is still 0. In the middle, this y value is 3, so times 1.5, 3 times 1.5 is 4.5. So 1, 2, 3, 4, and then a little bit more, so 4.5. And then the other one over here is 0, so I get this stretched out graph, just like that. One more, just for good measure. Want to make sure we're catching on and give you that chance to overcome any fear you have and ask a question. Example 6, the only difference I've made here, and it doesn't affect our procedure, is now instead of multiplying by a positive value of c, you're multiplying by a negative 2. Okay, so multiply all the y values by -2 and see what you get and connect the dots. Give it your best shot. Okay, so be careful on this one because there's more going on than the other ones. There's fewer y values of 0. So this first y value, what's the first y value of this leftmost point? Right now it is up 1. And when I multiply that by -2, what is that going to be? 1 times -2 is -2. So my new point, my new y value is -2. So I'm going to make a dot right there. The next y value, where is the y value presently on the black graph? +4. So then +4 times the -2 that's out in front, +4 times -2 becomes -8. So we got to go down to -5, -6, -7. There's -8 right there. The middle one, 0. 0 times -2 stays 0. Below here, this one is -4. So -4 times the -2 becomes +8. And finally, this last point, the y value is at -2, and -2 times the -2 is +4. So now I'm going to connect the dots. So I'm going to start on the left. I'm going to go whoop down to here, and then whoop, whoop, whoop. There it is. So notice my check mark has been stretched out. Also, because of the negative, we'll get into this a little more detail. That'll be the last thing we talk about today, but the negative also flips the graph, you notice. Okay, instead of the high point being over here on the left, that left becomes a low point because of that negative. All right, before we move on to horizontal stretching and how to identify that, I just want to bring up the idea of, okay, what if now we combine things? So flip back to example 1. So example 1, we say, okay, we did 2 times f of x. What if the question was 2 times f of x and then -3? And the reason I just want to do a couple of these is not because it's any different than what we've done. So I just want to clue you into the order of operations that's going to make your life as easy as possible. Okay. Because the question always is, when I have multiplication and when I have translations, what do I do first? Okay. And the thing that makes, I mean, you can do it in either direction, but the thing that is way, way, way by 10 orders of magnitude easier is to do your multiplying first. So do any stretching or shrinking first, then do the translating. So if I gave you this problem right here on the test, which I might, okay, there's going to be something that looks just like this. If I said do 2f of x minus 3, what you would do first is you would do the 2f of x part first and stretch it out. And then what does this minus 3 say to do to that 2 times f of x graph? I'm going to move it down 3. And so since you all are beginners at this, I expect you're going to have to do a little transition graph. And so what I would call this red graph right here is the transition graph. It's the stretching. And now I'm going to take the red graph and I'm going to drop it down 3 to get 2f of x minus 3. So here we go. 1, 2, 3. I move that point. This red point here, 1, 2, 3. The middle point, 1, 2, 3. This point down here at the bottom, 1, 2, 3. And finally, the rightmost point, 1, 2, 3. So I've just done here what we did in class last week on Wednesday. And I dropped down that red graph. So once again, in case you're writing this down, because I want you to remember this, if you are presented with a problem that has both stretching or shrinking and a translation, do the stretching or shrinking first. Do the multiplying first. It's way easier than translating first because then all the y values are messed up and it becomes a big hassle. So what I would like you to do for example 2, please, is we already did 3 times f of x. So I would like you to now do what 3 times f of, oops, sorry, wrote it wrong. What 3 times f of x minus 2 would look like. And notice where the minus 2 is. That tells you what to do. So the x minus 2, the minus 2 is attached directly to the x. So that tells me I'm going to do what with the stretched out graph? Right 2. That is right. Exactly. So here we go. 1, 2, and then 1, 2, and then the middle point, 1, 2. Everything's just going right 2 units. And there it is. And so here's my new graph. Beautiful. Now, I know when it comes to the test, you're probably not coming in with colored pencils or colored pens. So all I ask you to do, okay, is just draw an arrow to the final graph. So if I give this as your test problem and you're like, okay, I'm going to do my stretching like the Perkster said to do, and you do your stretching and then you move it, just draw a little arrow and say that this is the final graph, just so that I know and I'm not forced to guess what graph you are wanting me to look at. Okay, that helps me. All right, one more, and then we'll go to the other half of today's bit. So let's go to example 5. And for example 5, I would like you to do what 1.5 times g of x plus 4 would look like. Okay. I'm going to go through, I'm going to add 4 to all my y values, which is what I hope you did because that +4 is outside of the parentheses. So if you moved your graph left 4, what you did, okay, this would be the wrong thing. You did 1.5 g of x plus 4. So notice the difference. Okay, the +4 is not inside with the x. So this is not a left 4 problem. So we're going to move this up 4 units. So 1, 2, 3, 4, that end. Now this is 4.5. So 5.5, 6.5, 7.5, 8.5. And then 1, 2, 3, 4. So my stretched out moon shape gets moved up 4. That is vertical stretching and shrinking. Okay, and we've done lots of examples. I've given you lots of opportunity for a question. So please, I hope you're not leaving here feeling like, oh, you didn't get your questions answered because you haven't asked any yet. Okay, so ask away. All right, horizontal. Again, I've got the same typo as before, so at least I'm consistent in the things that I do. This should be c is greater than 1 down here at the bottom. So if you wouldn't mind fixing that for me. What we saw with horizontal translations, and we've been seeing today, is the horizontal translations are the exact reverse of what we would think. Okay, so you don't have to turn here on your sheet, but when we did this, 3 times f of x minus 2, we don't go -2 units, we go positive. It's the reverse. It's counterintuitive. And I told you that you have to get used to that with the x's. And the same thing is true with stretching and shrinking, with multiplying. And so I'm going to do my best to give you a nice, simple way to think about this after I have written up here the mathematical demonstration. So if c is greater than 1, so a number like 2 or 3 or 5 or 19, then the graph of f of c times x, so now I'm doing it inside directly to the x, and once again, it's counterintuitive. Okay, instead of stretching the graph out, what this is going to do is it's going to horizontally shrink the graph by a factor of 1 over c. And I'm just going to put in parentheses that what 1 over c means, in case it's been a while since you've done arithmetic, 1 over c just means the reciprocal. So if it's a 2x inside the parentheses, then what's the reciprocal of 2? A half. If it's 4 times x inside the parentheses, then what's the reciprocal of 4? Reciprocal of 4 just means you flip 4 and it becomes 1/4. If it's, here's a good one. Don't lose me now. If it's 3 over 2, then the reciprocal is 2 over 3. All you do, okay, so I'm going to write this down in a minute, but the simplified thing is when you're multiplying the x, you just multiply all the x values by the reciprocal. That is it. Okay, and I'm going to write that down, and if you're writing it down now, great. Okay, so I just want to, again, I'm just trying to make this as simple as possible because I know the x values tend to get a little more bulky. So if the value of c is between 0 and 1, then the graph of f times c of x is horizontal stretching. Again, by a factor of 1 over c. Again, the reciprocal. And while you're still writing that, I'm just going to summarize this in hopefully a way that'll make this easier for you to remember and carry along with you. Basically, to sum it up, all you're going to do is you multiply your x values by the reciprocal of c, whatever it is. Okay, so the summary of both of those rules whether the value is bigger than 1 or whether it's between 0 and 1, is you're going to multiply all your x values by the reciprocal of c and then make your new graph. I'm going to leave that up there for a minute because I know I write faster and messier than most of you do. So I don't want to get ahead of the game on you. Am I good to turn the page? Going once, going twice. Good. Sold. Okay, here we go. Next page. Example 7. I'm going to work example 7 with you, and then I've got, as you can see, a few for you to do. So I've asked you, I've given you the graph we were working with before. And what I've asked there is, let's graph f of 1/2 x. Well, let's write here, just so that we know what we're doing. When I have the 1/2 in front of the x, this means I'm going to multiply my x values by what? 2/1, or just 2. Yes, the reciprocal of 1/2 is 2. Beautiful. So I'm going to multiply all the x values by 2. When you're working with your x values, it's always the reverse of what it looks like should be obvious. I'm going to go through these points. Maybe you're already doing it. The first x value here is -4. So -4 times 2 is -8. So I'm going to put a new point at -6, -7, -8 right there. This x value is -2. So when I multiply -2 by 2, that's -4. So I'll put a point at -4. The middle point, the x value is 0, so 0 stays 0. The next point, the x value is +2, so +2 times 2 is +4. And the last x value is 4. 4 times 2 is 8, so that is right here. And notice we haven't done anything vertically this time. The stretching is all horizontally, left and right. And there's my graph. The wave has been stretched out. Turn your attention to example 8. It, again, is a super similar problem. I've just changed the number very slightly. And I know that this is going to go off your graph a little bit, so just do your best to guesstimate as you're plotting your points. Just to give everybody a nudge in case you're looking at this and you're like, I have no idea where to start. I've got a 1/3 here in front of the x. So that means I'm going to, and you should be multiplying your x values by what? 3. Yes. So I'll give you another 30 seconds to get started if you weren't already, or to finish up. I'm going to multiply the x values by 3. So the x value here is -4. So -4 times 3 is -12. So this is 10, 11, 12. I'm going to go right about here. This x value is -2. So times 3 is -6. So put a dot at -6. 0 stays 0. I don't know what that smudge was. There must have been a bug on the scanner this morning. Sorry, bug. So this next x value is 2. So 2 times 3 is +6. So I put a point at +6. And then the last one is 4. 4 times 3 is 12. So 10, 11, 12 right there. And so here's my super stretched out wave. There we go. Okay, just a couple more problems, and then I've got one more quick thing to mention, but if you understand what we've done so far, it's actually no new information. So we're doing good. What I would like you to do is example 9, giving you a graph, and now I want you to do g of 2x. Once again, just to make sure, I'm not going to do the problem, but just to make sure everybody's going in the right direction, I've got a 2 in front of the x now. So this says I'm going to multiply my x values by what? A half, the reciprocal. When it's done to the x's, it's always the reciprocal. So it's going to be by a half. Yes. So my x value is by a half. So the first x value is 3. Or excuse me, it's not. It's -3. So -3 times a half, or -3 times 0.5 is -1.5. So -1 and a little bit more is right there. The next x value is 0. So 0 stays 0. And the other x value is +3. So 3 times a half is +1.5. So 1.5. And so we have squished this graph like that. All right, last example, example 10. I'm going to give you something extra to do. So what you're going to do is you're going to do h of 2/3 x. Okay, so remember you're doing the reciprocal to all the x values. And then after you do h of 2/3 x, I would then like you to graph h of 2/3 x, and then let's go +6. And the +6, notice it's outside of the parentheses. It is not inside the parentheses. Because of the 2/3 in front of the x, that means you're multiplying your x values by what? 3/2 or 1.5. Beautiful. Well said. Keep going. First thing I asked you to do, because remember, whenever any stretching or shrinking is involved in a problem, always do the stretching and shrinking first, and then worry about the translation. So we're going to do the h of 2/3 x first, and you already told me that that 2/3 in front of the x means to multiply all the x values by 3/2 or 1.5. So my first x value is -4. -4 times 1.5, I believe, is -6. Correct me if I'm wrong. The next x value is -2. -2 times 1.5 is -3. Again, correct me if I'm wrong. 0 times 1.5 is still 0. This is 2. 2 times 1.5 is 3. And then finally, 4 times 1.5 is 6. So there we go, we're at 6. So this is my graph. I'm just going to kind of do it dotted just to not have all of our attention on that, since this is not the final answer. Okay, so that is the stretched out graph. Then what I asked you to do from there is now we're going to put a +6 outside the parentheses. So this +6 outside the parentheses, that means take my stretched out graph and do what with it? Yes, indeed, we're going to go up 6 with it. Perfect. So I'm going to take each of these purple points, 1, 2, 3, 4, 5, 6, boom. 1, 2, 3, 4, 5, 6, and then 6, and then 1, 2, 3, 4, 5, 6, and then finally 6. And so there is my stretched out graph. It's been translated up 6 units, and there it is. All right, we're almost done. You've done great today. I appreciate your endurance. Example 11. We've already done an example like this, so it shouldn't be too much of a trial. I've given you f of x, and this time I've put a negative out in front of it. When you don't have a number, I mean, this is introductory algebra right here. When you don't have a number right there, what do we assume is right there?
1.
-1, yes. So all you're doing is the same thing we've been doing. You're multiplying the y values by -1. So I'm going to multiply all the y values by -1. And so on the left, this y value is 0, so it stays 0. Now, what happens to when I multiply this y value by -1? It's presently 3. What's the new y value? -3. So it goes down here. So what I'm trying to show you, and I'm going to, before I finish the graph, I'm going to fill in this statement. When you multiply your y values by a -1. So down here, I'm going to slide my paper up a little bit. When you multiply your y values by -1, what this creates is a reflection of the graph. And the graph is going to be reflected about the x-axis. What that means is whatever was above the x-axis now gets reflected below. Whatever was below the x-axis now gets reflected above. Yes? No, it's not an inverse function. That's a great question. You're thinking ahead. We will talk about inverse functions either in the 3rd or 4th unit of this class. Good times. So I'm going to continue. This is just a reflection about the x-axis. So 0 stays 0. This y value is -3, so it gets reflected above to +3. And then 0 is 0. And so we see that my new graph, the blue one, which I don't know if you can distinguish it too much on the overhead, but the new graph is the reflection of the old one. I should pick a better graph for these 2 examples, and I'll do better next semester, although that does not help you. Sorry. So all we're going to do here for example 12, we're not going to actually graph example 12, but I just want to describe now the negative is in front of the x. So that means I'm going to multiply my x values by what? What's the reciprocal of -1? It's just going to be, you don't change the sign with the reciprocal, it's just going to be -1. You just flip, when you flip 1, you get 1. Okay, so when you flip a -1, it stays -1. So you would multiply the x values by -1. And it doesn't really come out great on this graph because it looks like the graph we just did. So like I said, I need to pick a better graph, but here's what I want to show you. That the graph of y equals f of -x, when the negative is in there in front of the x, it's a reflection about the y-axis. All the positive x's become negative, all the negative x's become positive. They just flip sides of the graph. So we've got about 10 minutes to go. So here's what we're going to do. We're going to go through a couple of these problems I have at the end. Any ones that we don't do when you leave here today, I will finish and post the recording online. So if you want to give them a try as part of your homework and see how you did, the answers will be part of the second video I post today. So what I would like you to do is let's go ahead. We already kind of did 13 and 14. I'll do those on the video. Let's flip the page. And example 15 is a super fun example. It's got a lot going on. Before you graph it, here's what I'm going to do. I want to give you 30 seconds. And right next door, I want you to write, what are the things happening to this graph? There's 3 things being done to the absolute value graph. So summarize that, please. There's 3 things, so figure out as many as you can. What's the first thing that you can identify as happening to my absolute value graph? Okay, sure, down 4. We'll do that. What else are we going to do? We're going to move left. How many? Left 2. Okay, so the -4 means down 4. The +2 means left 2. What does this negative out in front mean that I'm going to do? Multiply what values by -1? It's outside of the absolute value. So you're going to multiply the y's by -1. And as I've said a couple times, you're probably going to have to do this in 2 phases, which is totally fine. So phase 1, multiply all the y values by -1, and then phase 2, do the translation. But yes, it's going to be at some point part of the test. Yes. All right, just for time's sake, I know you're probably still working on this a little bit. So just to remind you, this is the only one we're going to get to do. So the 5 problems that I've skipped that have been combo problems, after class is over, I'm going to record them. I will post them. So when you get home, try them. And then you can check and see how you did. Okay, the answers will be there on that video. And then I will tell you why I gave you the packet for 2.4 in just a minute. But first thing I'm going to do always is whatever multiplication I have to do. And in this problem, we have to multiply our y values by -1. So I'm going to go through here. I've drawn in pencil so that it's a little lighter and doesn't mess us up too much. I've drawn my absolute value graph. So now I'm going to take some of the points and I'm going to multiply the y values by -1. So instead of +5, it's now going to be a -5. This point, instead of +3, will be -3. Instead of +1, it'll be -1. 0 stays 0. Instead of +2, it's -2. And then one more, instead of +4, it goes down to -4. So my graph, which I'm just going to do dotted here to try to not make this as messy as possible. My absolute value graph now has been reflected. That's phase 1. Are you with me so far? That's what the -1 did to the graph, is it reflected it. Phase 2, which I'll do in red to hopefully make it contrast enough on the screen. I'm now going to do the translation. That's always the second step. The translation, I'm going to move every point that I have left 2, down 4. So I'm just going to start over here with this point, and you can do this with as many points as you need to. I'm going to go left 2 and then down 4. 1, 2, 3, 4. This point right here, left 2, 1, 2, 3, 4. This point right here, left 2, 1, 2, 3, 4. The vertex, left 2, 1, 2, 3, 4. This point, left 2, 1, 2, 3, 4, and one more point, left 2, and then 1, 2, 3, 4. Remember, the translation should not affect the shape of the graph. Once you've done the stretching and shrinking, that's the new shape, and now you just move that graph just like that.